Hi, Assalamualaikum. Today I would like to present my FYP project. The title is Heat Extraction and Quality Assessment of Fish Oil from Patin Catfish Waste. My supervisor is Madam Noor Izzati binti Ibrahim. Firstly, background study. This study is about the oil that is extracted from fish waste to get the omega-3. Fish oil contain omega-3 fatty acid DHA and EPA, which provide numerous health and advantage for human. Patin catfish is the one of the source of high quality fish oil for human use. This fish has high growth rate and easy to breed. There are many extraction methods may be used to extract fish oil, such as heat extraction, solvent extraction, hydraulic grinding, enzymatic hydrolysis, and supercritical fluid extraction. This study only focus on heat extraction because it has simplest and low cost equipment compared to other methods. Next, the problem statement. The demand for omega-3 fatty acid is currently increasing due to expanding worldwide population and increased worldwide knowledge of the value of omega-3. The next problem is the disposal of fish waste is increasing widespread, which can cause several problems. The last problem is Patin catfish waste is extremely sensitive to handling, and even minor errors can cause harm to the extraction product, which is fish oil. This is the objective for the experiment. The first objective is to determine the best parameter for fish oil production from Patin catfish waste by heat extraction method. The second objective is to characterize the Patin catfish waste oil by using FTIR spectroscopy. The last objective is to analyze the Patin catfish oil quality by identify the acid value, peroxide value, P-anisidine value, and lipid yield. Next is literature review. Omega-3 fatty acid are long chain of PUFA that generally have 18, 20, or 22 chain of long carbon atoms. Omega-3 fatty acid cannot generate by our body, but it must receive from outside source, which is fish oil. The Patin catfish waste, if we handle properly and process properly, the non-valuable product can be turned to high valuable product. The increasing extraction temperature will cause faster free radical and FFA to form. High temperature can cause the process of oxidation, leading to a breakdown of fat. Methodology. The process starts with sample preparation. The fish sample was cleaned, dried, and blended. Next, we continue heat extraction. 20 grams of fish sample was weighed and added with distilled water. The heat extraction process was carried out under different parameters of type of waste, temperature, and time, and continue in the centrifuge. The centrifuge process will form 3 layers. Protein layer and bottom layer will discharge. Only upper layer will continue in the next process, which is oil characterization by FTIR spectroscopy and determination oil quality, which is acid value, peroxide value, P-anisidine value, and lipid yield. Next, result and discussion. This is the overall result for this experiment. Determination the best parameter for oil production. 3 parameters will be used to determine which parameter provide the higher percentage of oil. The first parameter is time. 15, 20 and 25 will be used in this experiment, and the next parameter is temperature. The different temperature will be used, which is 70, 80 and 90 degrees Celsius. And lastly, the different type of waste, which is guard, head and frame. As you can see here, the two highest percentage of oil yield produced are at the guard at a temperature of 80 degrees Celsius and the time at 20 minutes with 17.25% oil yield, and the frame at a temperature of 90 degrees Celsius at 20 minutes with 17.50% oil yield. The chosen parameter for best to produce oil was at a temperature of 80 degrees Celsius and 20 minutes with 17.25% oil yield. Next, the graph effect of time on oil yield at the temperature 70 degrees Celsius. As you can see here, the longer time taken, the higher production of oil yield for every sample. At 15, 20 and 25 minutes, each type of the waste increment in produced oil yield, proving that the protein at 70 degrees Celsius does not undergo irreversible denature. Next, graph effect of time on oil yield at the temperature 80 degrees Celsius. From the graph, at 80 degrees Celsius and 20 minutes, the Patin Catfish guard is the best parameter which produce 17.25% oil yield. The longer the period, the larger oil yield production, but it decreased until the time at 25 minutes for each sample. The oil yield show a decrease at 25 minutes because 25 minutes was the longest time taken for heat extraction at maximum temperature 80 degrees Celsius. So the protein tend to undergo irreversible denaturing. Next, the graph effect of time on oil yield at the temperature of 90 degrees Celsius. From the graph, at 90 degrees Celsius, the oil yield increased as the time for each run was increased. 90 degrees Celsius was a high temperature for the heat extraction process. The longer time taken for heat extraction may degrade the quality of the oil and reduce production. At this temperature, the protein undergoes irreversible denaturing when heated to 90 until 100 degrees Celsius, and denature protein that form a dense structure may inhibit oil release. Next, result and discussion for second objective. This is the functional group analysis by FTIR spectroscopy. As you can see in the table, there are alkene functional group was used to prove the unsaturated fatty acid was present in the fish oil sample. In the table also has 3 ester functional group which prove the fish sample has triglyceride compound. The triglyceride contain various amount of EPA and DHA as fatty acid attached to glycerol. This unsaturated fatty acid representing a functional group of alkene proof fatty acid and PUFA species such as DHA and EPA in the fish oil sample. The last result and discussion for oil quality analysis, the acid value a little bit higher than allowable limit that set by FAO. Peroxide value and P-N-acetylene value that low than allowable limit that set by FAO. And the last is lipid yield. For gut is 15%, oil lipid yield, frame is 13.47% lipid yield, and head is 7.75% lipid yield. For conclusion, I already achieved all the 3 objectives in this experiment. The best parameter obtained from experiment is at 80 degrees Celsius, 20 minutes, and at the gut part that produce the oil yield with 17.25% oil yield. Based on FTIR result, there are 3% ester functional group and proof there was triglyceride compound in the Patin catfish waste oil sample, while presence of alkene that consists fatty acid and PUFA species such as DHA, EPA proving the presence of omega-3. The acid value is above the allowable limit, while the peroxide and P-N-acetylene value is under the acceptable limit. Thank you.